Hello CS111 students. This is my problem set explainer video for problem set 5 task 3 musical scales. And this is another one of those optional tasks where you get to choose between doing something with Turtle and doing something with music. And this time it's either task 3 or task 2. One of those two. You don't have to do both, but you do have to do task 1 and task 4. So 1 and 4, and then either 2 or 3. 2 is Turtle, 3 is music. And this time we're going back to that synth module, and we're going to be making musical scales. And a scale is just a sequence of notes that goes up and then comes back down. This is going to be useful for us to learn a little bit more about for loops. So there is a synth.py module, and probably if you're choosing to do this task, you have chosen to do the previous musical tasks, and therefore you're already familiar with this module. But if you're not, there's a link here to problem set 2 task 4, which has a little introduction to the module and an explanation of how it works. You should go back and look at that material. There's also a reference page for it, and a lot of the functions that we mentioned are linked in the problem set description to their reference page entries. So we hope that you'll read some of that material and understand how to use these functions. The ones that you'll need for this task are add note, half step up and step down. You're going to use print track, save track, and or play track for testing, but we have supplied testing code. No, we have not supplied testing code, sorry. We have not supplied any starter code, although we've given you some code that you can copy paste into your file if you want. To help you out with testing stuff. And the one of the wrinkles here that, again, probably if you did one of the previous audio tasks, you did this, but you'll have to install the simple audio module in Thonny if you want to actually hear the audio when you run Python. If not, it'll save an audio file that you can play. So, as I just mentioned, accidentally, you're going to be creating a new file for this task. So we're not giving you a starter file. It's up to you to create a file from scratch. We've supplied here the comment you should use at the top, and you should fill in, of course, that comment as you usually do. And then you're also going to need this import, and we recommend saying from synth import star. That'll let you use the functions without using the name synth dot before them. There are 4 parts to this task. In part A, you'll create a very simple fixed length scale. So it's just all the same all the time, no parameters, or maybe one parameter, we'll see in a second. But it is very simple and not variable. In part B, you'll have a variable length scale, and this one is going to use whole steps instead of half steps, so it'll sound a little bit different. In part C, we make things even more complex, where you have a variable length scale, and the notes are alternating long and short, long and short. It'll sound pretty cool, but it'll take a little bit more programming to get done. And then in part D, you have your freedom to create whatever kind of pattern you would like with a few restrictions on what functions you call and what kind of loops you set up. We have here some testing code that you can copy paste into your file, and we recommend that you do that. You could, of course, do your own testing if you want. I've seen a lot of people comment out these testing code blocks when we give them to you, and I'm not totally sure why, although I would guess it comes from a sort of misunderstanding of why they're there or some worry about they might not work correctly. But at this point in the class, you should be able to understand what this testing code is doing and why, with the possible exception of the name equals main thing here at the end. And if you have questions about that, I do recommend that you ask on Piazza or drop by drop-in hours, or just ask in class. So let me go through the parts here. Part A is half-step scale. This is what you call a chromatic scale if you are into music. And there is a parameter, just one, which determines the duration for each note. So you can have a scale with longer or shorter notes, but it always has the same number of notes. And a half-step scale doesn't return anything. It's not fruitful. When it's called, it has to add 13 notes to the current track, starting at the given base pitch, or sorry, starting at the current pitch, and ending up with the note that's one full octave above that current pitch. So you're going to go 12 half steps up, And you'll just use the half step up function to do that. After the scale is done, it should leave the current pitch there at the top of the scale. And so when you call this function, if you called it twice, for example, you would get two scales, and the second scale would start with the note that the first scale ended with. Half-step scale should not change the volume level. None of the functions in this module are going to change the volume level at all, so just don't touch the volume and you should be fine. We have an example that you can play that shows you what half-step scale sounds like. And then we have some code that will produce the same audio track if you have implemented half-step scale correctly. We also show here what the printout of the track looks like. So you can compare that using a text difference checker if you want to make sure that you have the exactly correct notes. Or you could just look at it with your human eyes and see if you have things correct or not. So that's part A. And again, this is all sort of for loops practice that we're doing here. So you should be able to solve this with a relatively simple loop. Part B is just called scale. And it's going to have two parameters. One controls the duration of each note, just like in half-step scale. And the other one controls how many notes are in the scale. But it's a little bit more complicated because it doesn't just directly specify the number of notes. It specifies the number of notes going up, but then scale is going to go right back down to the original note. So it's going to add a series of notes that are going up, and then another series of notes that go back down to the original note. So, as I just explained, the second parameter is telling you how many notes are in the ascending sequence of the scale. So, for example, if that second parameter is 3, you would have 3 notes up, 1, 2, 3, and then 2 notes back down, 1, 2, 3, 2, 1, back down to the original pitch. Each note is one full step above or below the previous note in this sequence, and the top note only appears once. So 1, 2, 3, 2, 1, not 1, 2, 3, 3, 2, 1. You have to figure out what this means in terms of what kind of loop or loops you're going to use to add these notes. That's sort of the meat of this problem. The second argument is always going to be at least 1. We're not going to give you 0 for the number of notes. If that second argument is 1, then the scale is just a single note at that pitch. Just one note. If it's 2, it would be like 1, 2, 1. So 3 notes. And we've given you more examples here of what the notes would be if you started at a certain place and how many notes total for different numbers of arguments that you can look through. We've also given you an audio track you can play to hear what it should sound like and an example of the printout that you should be able to get when you call print track after calling your scale function with particular parameters. We've even given you 2 of those so you can compare with different parameter values. So that's the scale function, and then part C is uneven scale. And uneven scale works just the same as scale. It has 2 parameters, the duration of each note and the number of notes going up. The only difference is the first parameter isn't actually the duration of each note, it's the duration of some of the notes, about half of the notes. Every other note is going to be half as long as that duration value. So you're given a base duration value, half the notes are that duration, the other half of the notes are half as long. The top note of the scale is always a long note, and that has some important implications for how you set up your code. So no matter whether the number of notes going up is even or odd, the top note of the scale is always a long note. That means that the first note of the scale and the last note, they might be short, they might be long. It depends on, again, whether there's an even or odd number of notes going up the scale. An example of that concretely is if we have 3 notes going up, we'll have 1, 2, 3, 2, 1 in terms of the pitches, right? And the third top note is going to be a long note. So the second and fourth notes are going to be short notes, and the first and last notes are going to be long notes. We'll have long, short, long, short, long. And there's another example in the text that you can read about what if there are 4 notes going up. And we have provided 2 different examples with an audio file and a printout showing you what the correct behavior is. So that's uneven scale. And you'll have to be thinking as you do your loop about, okay, how do I manage switching back and forth between short and long notes in the context of the iteration that you're doing. There's several different ways to do that. The last part is called MyScales, and it's a space for you to be a little bit creative. The requirements are that your function has to take a single parameter for note duration, just like the other functions in this task. You have to use some kind of loop in your MyScales function. It can be a for loop, it can be a while loop, some kind of loop. And in that loop, you have to call either scale or uneven scale at least once. You can call them multiple times, you could call both, but one of those 2 functions has to be called inside that loop. And of course, with that restriction, you're going to be doing something that is pretty complicated in terms of the musical output, right? Because you're going to have multiple scales happening. So of course, there's no correct solution for MyScales. It's up to you what kind of pattern you want to produce. But we've given you 2 different audio files that both are produced by functions which satisfy those requirements that we gave you. So that's it for this task. There are already videos for the other tasks in this problem set. So I will sign off here.